Hey there, and welcome. Today, we're going to get down to the basics of, well, pretty much everything around us. We're going to explore the fundamental way all matter is classified, either as a pure substance or as a mixture.
So, let's just jump right in with a question. Go ahead, take a deep breath. The air you just pulled into your lungs, what is it really? Is it one single pure thing, or is it a jumble of different things all mixed together? Stick around, because by the end of this, you're going to know the answer for sure.
To get to the bottom of this air puzzle, we need to make sure we're all on the same page. That means we have to get our definitions straight. What do scientists actually mean when they talk about a pure substance versus a mixture?
Okay, let's dive in. It turns out that every single physical thing in the entire universe, I'm talking from the salt on your fries to the most distant stars, can be sorted into one of just two basic categories.
So let's start with that first category. This is our first major clue in solving the mystery of air, and it's all about purity.
A pure substance is, beautifully simple. It's made of only one kind of building block. Imagine you have a bag filled with nothing but identical red marbles. Every single particle is exactly the same as the one next to it. That's a pure substance. But here's the thing. Pure actually comes in two different flavors. First, you have elements. These are the simplest building blocks there are. Like pure oxygen, every particle is just an oxygen atom, period. But then you also have compounds. Think about table salt. Now, it's made of two different atoms, sodium and chlorine, but they're chemically locked together to form one single repeating particle. And because every particle is that identical salt molecule, the whole thing is still considered pure.
All right, so that was our first category. Now let's look at the second one, where things aren't quite so neat and tidy. This is the other possibility for the air we're breathing.
And this right here is the absolute crucial difference. A mixture has two or more different substances that are just hanging out in the same space. They're physically combined, kind of like a bunch of people in a crowd, but they haven't chemically reacted to become something totally new. They're more like roommates, not a family.
But, not all mixtures are created equal. You can really think of them in two main ways. Are they smoothly blended together, or are they kind of chunky and uneven? This slide breaks it down perfectly. On one side, we have homogeneous mixtures. Homo just means same. These are mixed so incredibly well that they look like a single thing. Take salt water. You can't see the individual little bits of salt, right? On the other side, you have heterogeneous mixtures. Hetero means different. And with these, you can easily see all the separate parts, like every grain of sand sitting at the bottom of a glass of water. Okay, so we've got our definitions, we've got our clues. I think it's time to put this knowledge to the test. Let's see if we can classify a few everyday things. Let's walk through these. First up, salt. Well, it's made of just one type of particle, that sodium chloride molecule. So, boom, it's a pure substance. Next, sugar water. We've got two substances here, sugar and water, but they're mixed so evenly you can't see the sugar anymore. That makes it a homogeneous mixture. And last, soil. You can literally see different bits and pieces, dirt, tiny rocks, maybe some leaves. It's a classic heterogeneous mixture. You see the pattern here? All right, time for a quick pop quiz to really make sure this concept sticks. Think back to that sand and water example. Could you separate them without some big chemical reaction? Yes, absolutely. You could just pour the whole thing through a coffee filter to catch the sand, or you could just let the water evaporate and the sand would be left behind. And that is a huge defining feature of mixtures. Because the parts aren't chemically glued together, you can usually pull them apart with simple physical tricks.
So now we have all the tools we need. It's time to circle back to where we started and finally solve the mystery of the air all around us. Let's break down the air using our new system. First question. Is it made of multiple substances? Oh yeah, it's mostly nitrogen, but there's also oxygen, argon, and a bunch of other gases in there. So check, it's a mixture. Second question, are they mixed evenly? Well, you can't see the individual gases, can you? It all looks like one clear, uniform thing. That tells us it's homogeneous.
And there it is. There's our answer. Air fits the definition perfectly. It is a mixture of multiple gases that are not chemically bonded, and it's a homogeneous one because they are all mixed together so smoothly that it appears to be a single substance. Mystery solved.
Look, if you remember just one thing from all of this, let it be this right here. The whole game of classifying matter really comes down to one single question.
Are the pieces chemically locked together to make something new, or are they just physically hanging out and sharing the same space?
So now that you know what to look for, think about your day. That cup of coffee you had this morning? That's a mixture. The milk you poured on your cereal? A mixture. The steel that makes up your car? Yep, that's a mixture too. Once you start looking, you'll realize they are absolutely everywhere. Thanks for tuning in.